First of all, let me quickly introduce myself. Thank you for doing some of that for me. So, as mentioned, my name is Oz. I work on an open source project called LakeFS. I have about 15 years experience working on data lakes before they were called data lakes. We used to call them data warehouses. We used to call them shared folders at some point. Together with me, I'm going to present Lottie. That's her mascot, and she's super cute. She's actually VP Cuteness for the project, so a nice title for her as well. I don't know if there's an award for that, but if there is, she should win. She has about 200 million years of experience with lakes, not so much with the data part, but just with being cute within them. So with that, let's talk a little bit about data lakes, what they look like nowadays. If you can just raise your hand if you are familiar with the terminology, what a data lake is. Great. I'll speak a little bit about the challenges, or at least the ones that I'm somewhat painfully familiar with. And I will show you LakeFS as a tool and a set of processes that you can build using it to help kind of alleviate some of those challenges. So with this is an actual screenshot that I took yesterday. This is my desktop, okay? So unlike Lottie, I'm human. I'm not very good at organizing things. This is what it looks like. And you can think of this as kind of a sample of an actual data lake, because most of the data, while it's being transformed and written and ingested by systems, these systems are maintained and written by us humans, unfortunately. So a data lake is essentially, let's take this kind of mess that I created locally and just multiply it with the amount of people who are reading, writing data, processing it, using it with their pipelines. And especially if you're a data scientist, these guys tend to be the messiest of all. I don't know why, but that's the way it is. So apologies to you if you're a data scientist. I have all the love in the world for you, but stop being so messy. This is an actual screenshot. Well, it's not a real system, but it's close enough. So this is S3. Anyone familiar with this UI? This is your life, right? So as you can see, we have all these directories. Somewhere hidden here is like a very important data set that's serving actual production use cases. And of course, it's not going to be the one called prod. It's going to be the one called test_blah, because someone decided. And it's a mess. So why is this Why is this painful for us? First of all, especially when we talk about more advanced use cases for data lakes, so not just analytics, but also data science and machine learning. Science is about reproducible experiments, right? I train the model, it's used in production. I want to be able to run the same training job and get the same result. But we're working on this huge shared folder, and it's not that easy to do, right? So if I trained it yesterday with some set of parameters on a set of input data, that input data might have changed, not even since yesterday, but while I was actually processing my job. Additionally, if I want to run whatever it is, if it's a pipeline, ML job, whatever it is, if I want to be able to run it without actually touching production data, right? Not running on production, but on some isolated environment, this is also really difficult, right? Because I don't have an entire copy of my data lake, right? Especially if it's big. So either I do sampling, right? I have a small portion of my data that's not always going to be representative of the actual data. Or worse, I don't have anything at all. Right? And neither of these are very good options. And of course, when we don't have a staging environment and when we don't have a test environment, it means we're running typically directly on production. Right? We have an ETL pipeline, we have something business critical. It's going to be directly talking to the S3 bucket or the Azure Blob Store, whatever it is that's people actually consuming and making decisions off of that data directly. Not a very fun ecosystem to be working in. It's very error prone. It's very dangerous. So with that, let's talk a little bit about LakeFS, which, as I mentioned, is an open source project. So what is LakeFS? I'll try to keep the description of it very brief. I'll put it in the words that, like I heard one of our users actually call it, which is the bastard child of GitHub and S3 in a way. So the idea is it's a system that actually wraps existing object stores, right? So all the common ones for all the cloud providers, and enriches that object store with a set of capabilities that are very similar to Git, essentially. Right? So what if I could take my giant S3 bucket, click a button or run an API call and get a branch without actually copying all the data? And on that branch, I can do whatever crazy mess I want to do. It's all isolated to me, right? And I didn't have to create that huge copy that's hard to maintain. And that's what LakeFS is, right? So in the middle column, you can see like all the common data technologies. Essentially, if it can talk to an object store, it can use LakeFS. All you have to do is stick a reference in the middle, right? This could be a commit ID, it could be a branch name. In this example, it's main or my experiment. You can do all the things that Git would let you do, but you can do them on petabytes of data, essentially. So as I mentioned, it's open source. It's on GitHub, Apache 2 licensed. You can just do a Docker run and get a running instance of this. It's not a storage system by itself, right? It relies on some underlying object store. Just manages the metadata and essentially pointers to objects on the object store. So when you say, give me this set of files from main, LakeFS would actually translate it to a set of objects on S3 that need to be written. And we have clients that know how to do this translation kind of behind the scenes. So how did this help us? How does the Git concept actually help us with the challenges that we talked about? So first, when we talk about reproducibility, kind of the key aspect here is not just my code that needs to be reproducible. That's the easy part, right? That lives on Git. It's also the input data and the parameters that I use and the environment that I use. And if I'm using something like LakeFS and I have the concept of commits and tags, I can simply say, I want to branch out, run my training job on its own isolated branch. If I'm happy with the results, I can commit and attach a tag to that. If I come back tomorrow or the day after or in a year, if I run the same code, assuming it's deterministic, and I use that same tag, I'm going to get back the same results. Right? It sounds trivial, but when you talk about large amounts of ever-changing data, it's not that simple. Dev test is essentially just creating a branch. Right? So with LakeFS, you can simply kind of import your existing data. Right? It could be billions of objects. You click a button, it will just kind of map the existing objects that exist without actually copying them. And then with a click of a button, you create a branch. Right? It could be staging. It could be Oz's crazy experiment. It could be whatever it is that I want to do. And on that branch, go crazy. It's isolated to you. We use copy on write behind the scenes. So everything I do on my branch exists only for my branch until I decide to merge it. All right, so a fun experiment. Let's try and delete half the data and see what happens. Let's run Airflow and hope for the best. We can actually do that now without fearing that we're going to break production. And the last thing, we can use kind of the same concept we saw on the last talk, GitHub Actions. LakeFS has kind of a similar concept built in, where I can say everyone can do whatever crazy things they want on their own isolated branch, but if they want to merge it to whatever everyone else is seeing, it has to pass a set of validations. Right? This could be data quality checks, it could be schema validation, whatever good practice I have that I want to enforce, right, so that my data lake doesn't look like my desktop, this is the place to put it. And if something does go bad, I can always just, with a single click, just hit a revert button, which I always wished I kind of had with S3. So the cost of mistake is much lower, right? Even if I do screw things up, I'm human, it happens. I just hit that button, and I can take all my data lake back to kind of the last known good state of it. So we solved for reproducibility. It allowed us to create that dev test environment and to do it very cheaply because branches actually incur no cost until I write data to them. And we got that production safety just by being able to roll back and kind of enforce best practices. So yeah, this is LakeFS. As I mentioned, it's open source. Feel free to check it out, contribute, join our Slack, store it. Happy to talk after this talk. I'll be right outside if you guys have questions.
Great.
Thank you.
Very much.